Hello everybody, my name is Professor Diaz, and today we're going to do our first online video demonstration on the preparation of 2-chloral 2-methylbutane. In front of me, I have all of the solutions and the glassware that I'm going to be working with today. The solutions are on my right-hand side. Notice that they are beyond the neon green line that is inside your hood. All of your chemical solutions need to be worked with beyond that line. And notice that the hood sash is indicated by this arrow here. This is where you're getting the optimal ventilation so that you know that you're being safe. I'm going to lower that for a minute so that you can see inside of the hood. I have my 125 separatory funnel, my 10 ml graduated cylinder for water with a bottle of DI water next to it, and my 1 liter beaker labeled aqueous waste for my wash. So we're going to start by me demonstrating how to use the glass repipetter. Your faculty may instruct you to do this differently, and you're to follow their guideline on how they want you to hold and dispense the solutions from the repipetter. Always keep the repipetter in secondary containment. If there's any dripping or spillage, it should fall into the secondary container. We're going to use 10 mLs of our starting product, that's 2-methyl-2-butanol, to fill this repipetter. I'm going to invert it, carry it over directly over my graduated cylinder with one hand, and slowly repipette my contents inside my graduated cylinder, allowing all of the drops to fall inside. Place that back in secondary containment. I'm going to make sure that my separatory funnel is in the stop position, noted here. I'm going to remove my stop pot, and I'm going to slowly pour my contents inside. Your procedure next says to add 25 mLs of 12 molar hydrochloric acid. Notice that the hydrochloric acid has a white solid on the bottom of the secondary container. That's sodium bicarbonate, and it's used as a neutralizing agent. Should any of the droplets fall into the secondary container, they will be neutralized. You'll hear a hissing sound, and that is just fine for the neutralization of any concentrate acid that should fall in here. I'm going to hold my repipetter with my dominant hand. I'm going to invert it just like I did before, allowing the container to fill on the inside chamber. Once that's full, I'm going to swing that around, aim it right over the graduated cylinder, and carefully decant my pre-measured 25 mLs. This class is not quantitative, so you don't have to get every last drop out. It's just an estimate. I'll return the decanter back to the secondary container, and slowly I will add my acid to my extraction points. At the end, I should neutralize my graduated cylinder with a 5% solution of sodium bicarbonate before I attempt to wash it. That'll make sure that all of the acid is neutralized on the inside. So your procedure next tells you that hydrochloric acid has a very high vapor pressure. And because of that, I'm going to start this experiment by swirling the contents inside carefully, but making sure that the solutions are mixing without the cap. And that's important because if you forget, that cap will pop off because the pressure inside will be so great it will force the cap out. So we're going to do this for approximately 1 minute, and we do not have to time it. This is just an estimate. So that's approximately 1 minute. And now I'm going to return it back to the ring stand. So at this point, the next step in your procedure is to do an extraction by shaking the contents on the inside semi-vigorously with the cap on. When I do this, there's going to be a lot of vapor pressure that builds up inside the separatory funnel. We don't want to allow that vapor pressure to continually increase. That vapor pressure will cause this cap to pop off. In that case, the contents would spill out inside, they would end up in your hood, and they would end up on yourself. And this acid is very concentrated. So rather than allow the pressure to build up, I'm going to vent the cap facing the back of the hood. Not to my partner, not facing me, and not facing outside of the hood, but to the back. Should any condensation fall out during the venting process, it will splash towards the back of the hood where it belongs. So I'm going to put my cap onto my set funnel, and I'm going to slowly take it out, and I'm going to do this for 5 minutes. At this time, I'm going to rely on my assistant to tell me when that 5 minutes is over. You may not hear that hissing sound, but in lab you will. That hissing sound is your CO2 byproduct coming out. And notice that the solution is changing from clear and colorless to a more opaque, creamy white color. Notice that I'm holding the flask with both hands and that my index finger is firmly holding the stopcock inside to make sure that it does not fall out during the venting process. Okay, so now that my 5 minutes have elapsed, the next part of this procedure is to put this back on the ring stand and allow the contents to settle so that you see a distinctive phase boundary, clearly separating the aqueous layer from the organic layer. And now I'm going to drain the lower aqueous layer and separate it from the organic layer. At this point, you want to remove the stopcock. And very carefully drain that aqueous layer out. Now this aqueous layer is very acidic, and you know that. You can see these condensation building up on the inside. So at the very end, we're going to tell you how to properly recover this aqueous layer. The next step in your procedure is to wash the organic layer with 10 mL of water. You're going to allow the contents of the funnel to stand until you again see two distinct layers. This measurement does not have to be precise. Allow your contents to sit and be patient. And then again, I'm going to drain out the lower aqueous layer and put that into my aqueous waste beaker. Notice now that there's two very distinct colors, and it's much easier to see the phase boundary than it was before. Note all of these color changes in your notes. The next step is to do one more wash with 10 ml of 5% sodium bicarbonate. Again, this is an estimate, and the volume does not have to be exact. I'm going to slowly pour my 5% sodium bicarbonate into the extraction flask. And I'm going to put the stopcock back on, rocking it slowly, a total of 3 times. Remember that the vapor pressure from the hydrochloric acid is very high. Now that we are neutralizing the residual acid with the sodium bicarbonate, we want to make sure that we're venting to prevent any pressure buildup. The pressure can be strong enough to actually dislodge the stopcock even with my hand remaining firmly on it. And that is the third time. Return it back to my ring stand. Take the stopcock off. And allow the contents to settle before I drain the aqueous layer from the organic layer. We want to remove as much of the aqueous layer as we can, because at the very end, we're going to use a drying agent to remove all the residual water that's still inside the system. So it's better to lose just a little bit of the organic layer rather than keep too much aqueous layer in your final product. At this point, you'll see some bubbling occurring in the aqueous layer. That is the sodium bicarbonate now neutralizing the highly acidic aqueous wash. Remove the aqueous layer, again, with 10 mL of water. The purpose of these extractions is to remove and neutralize the remaining residual hydrochloric acid from the final product. Again, this measurement does not have to be accurate. A good rule of thumb for these extractions is that each one should last about 5 minutes. That's been 5 minutes. So now, I'm going to put my final solution inside the ring stand, but I'm going to kind of agitate the solution around, trying to get those droplets down inside. And I'm going to patiently wait for there to be 2 distinct immiscible layers. You notice that there's bubbling on the inside. You want that bubbling to settle. That is a slight emulsion. It will go away. Take your aqueous wash beaker, put it back underneath, and drain the aqueous layer out. By draining it out, we're going to pour it out. And the reason why is because, as you can see, there's some condensation right at the end of the extraction flask. And we don't want that aqueous layer to mix with our final product. So rather, I'll just slowly pour it over the drying agent. To dry your final product, swirl the contents of the organic layer with the calcium chloride. Notice that some of the calcium chloride has started to clump together. That's a sign that there was a slight water contamination. If you see one giant clump of calcium chloride, consult your professor to troubleshoot that. If your calcium chloride dissolves entirely in your final product, you've made a gross error. Calcium chloride is soluble in tap water. It is not soluble in the organic layer. Your tip. Tilt your Erlenmeyer flask slightly so that the solid calcium chloride falls to the bottom. and very slowly decant your final product into an appropriate recovery vessel. In this case, I'm using a beaker with the intention of transferring it into a tiered weighing glass. Note the color and the clarity of your final solution in your notebook. Do not forget to weigh your final product for your % yield calculation.